So some visualization types like lines and heat maps are really intuitive. Like these are either things that we encounter so often in real life, like a simple line graph, or things that are so intuitive, like a heat map, that it's easy for users just to get them right off the bat. But there are other common visualizations that are a little bit more complicated, have a little bit more statistical heft to them, and so we really do need to kind of remind ourselves what the heck is going on with some of these. And one in particular is Boxplots. So they're both very common and have a lot of details. And this is kind of a tricky combination. So let's do one example of just one box plot to remind ourselves how various features of this visualization are related to things like centeredness, like where the distribution is centered, and spread, how spread out the data set is in general. So to do this, we're going to be working with our bookshop data set, and let's just make a new sheet. And you just have to pick a question to answer here to kind of anchor the discussion. So let's do sales by book. So what does the distribution of sales by book look like? So as you can imagine, there's a bunch of ways to think about this and visualize this. But the first part of all of them involves just getting the data into the appropriate shelves. So we're going to be doing book. Let's do the title as detail. So I have 1 point for every book in the data set. But I haven't told Tableau what these points are going to represent. So let's go down to sales and drag in the count of sales to my rows. So what this does by default in Tableau is gives us a bar chart where the total sales is the size of the bar, and so we have about 56,000 sales total in this data set. And what it's saying is about 4,000 of those sales correspond to this book, about 4,200 of those sales correspond to this book, and so on and so on. So it's just broken up the total number of sales into which book they came from. So the issue with this is, well, first of all, it's good, right? Like you could answer some questions here, and you could answer, like you could change this slightly, for instance, to like a tree map and like maybe give a better visualization. But there are many questions that this visualization does not answer. For instance, like what does a typical book look like? What is the, like the sales of a typical book? So I see some fat bars here. I see some skinny bars here, but I don't really know, like, are there more fat than skinny bars? Like, is it more common for a book to sell a lot, or is it more common for a book to sell a little? Like if I launched a new book, kind of where and what range would I expect its sales to lie? It's kind of hard to know, and so we need a slightly different visualization to give us an idea of the distribution here. And so you could think like histogram, like that's a fine choice, but let's give a little bit more detail here and actually do a box plot. So to do that, we have to override the default of Tableau, and the easiest way to do that is with the show me. So remember, in show me, basically Tableau is saying, given the combination or the mix of dimensions and measures you currently have loaded on your shelves, here are the visualizations I think would be most appropriate. And it's done just a simple bar chart so far, but we want to do a histogram. Notice that other good options here are things like tree maps, like I mentioned before. Let's do our box plot. So notice that still each point is corresponding to a title, and that hasn't changed. But notice already I see stuff that I didn't see before. Like I now know what the best-selling book is, and then I can see that it's by far and away the best, like way off on its own league. There's a group of very well-selling books, and then there's a bunch down here that are kind of more typical. And then also down here I see the box in the box plot. So what is going on here? Well, let's start with the middle of the box and work our way out because they all kind of depend on each other, all these ideas. So notice here in the middle, not in the very center of the box, but there is a kind of a distinguish between the top of the box and the lower part of the box, between this light gray region and this dark gray region. The line that separates the two is the median. So this is the value for which the book for which if we line books up from the worst selling book to the best selling book, it's the book right in the middle of that distribution, or as close as we can get. Like if there's an even number, you might take the midpoint between those two. But imagine you have an odd number lined up, like 7 books. It's the fourth one, the one right in the middle. So what do we do with this information? Well, what this is saying is if this is the median, then 50% of the books lie above this break here, and 50% of the books lie below. So already, notice what a powerful statement this is. There's the same number of books in this tiny little region here as there are in this huge region up here. Okay? 50% of books lie below this value, and 50% of books lie above this value. This is already, like, it's already saying, like, most books don't sell super well. Like books, when you see books up here, these are not at all representative of the whole. 50% of books actually sell less than 355, and I'm getting that by hovering over the box itself, and you can get these values here. We're talking about the median. So let's talk about the other ones. So the upper hinge and the lower hinge, this upper hinge is this value right here, the top of the box, and the lower hinge is this box here. So if the median is representing the value where 50% lie above and 50% lie below, the upper hinge and lower hinge are the values for which 25% of the data are located right here in the gray box between the median and the upper hinge, and the lower hinge is the value for which 25% of the data lie between the median and the lower hinge. So basically what this is saying is 25% of the data points lie below the lower hinge, 25% of the data points lie between the lower hinge and the median, 25% of the data points lie between the median and the upper hinge, and 25% of the data points lie above the upper hinge. And said yet another way, these are just the quartiles. We have quartile 1 as the lower hinge, the median is quartile 2, and the upper part is quartile 3. If quartiles and like all that stuff from statistics is a little fuzzy, just think of it as 25% of data here, 25% of data here, 25% of data here, and 25% of data here. 25% of data lies within each range. So what this is saying, yet another way, is that 50% of the data points lie between the upper hinge and the lower hinge. In fact, this box represents the middle 50% of the distribution. So the wider this range is, the more spread out our data are. So if this range is really wide, it means we need to look over a large range of sales in order to see the middle 50% of books. If that range is small, the distribution is actually pretty tight because we actually need to look over only a very small range in order to see the middle 50% of books. So this range here, which is known as the interquartile range, or IQR, is a proxy for the spread of a distribution. This is a measurement of the spread of a distribution. The bigger this box, the bigger the interquartile range, the more spread out the distribution is, because the wider I need to look in order to see the middle 50% of my observations. So that just leaves us with the whiskers then. So what are these whiskers? So the whiskers are telling us something about farther out data points, like data points that are farther from the median. So this is where interquartile range comes in. I said everything builds out from the middle, and we need the definition of interquartile range to talk about what these whiskers are. So the whisker, so imagine I took this box, the box is linked here, the IQR, the interquartile range, and I looked up one interquartile range and then a half. So 1.5 interquartile ranges from the upper hinge. So I basically took this box, I copied it up again, and I copied it up again a half. And I drew a line. This whisker is the first value, or I'm sorry, the last value that lies below that line. So I look up here, I take my upper hinge, I go up one interquartile range, I go up another half, I draw a line, and I find the first data point that lies below that line. That's in some sense like the farthest out data point that's less than 1.5 interquartile ranges from the upper hinge. I know it gets kind of needlessly technical, but basically what it's saying is where is a good line to draw between, in this data set, between like pretty close to normal and like not normal at all. And that's what the whiskers are telling us. So we look 1.5 interquartile ranges from the upper hinge to say like that's kind of what we would expect to see in kind of a lot of sales, but not a really abnormal amount of sales. Whereas these points here, which we might start considering as outliers, like really like in a formal sense, these might be outlier observations that are not anything related to what a typical observation might look like. These outliers lie outside of those whiskers, So similarly here, if we were to look at the bottom whisker, we would look at 1.5 interquartile ranges below the lower hinge. So I take the lower hinge and I go one interquartile range down and then another half. And then I find the data point, the last data point that lies just above that. Because our sales are capped or can't be any lower than 0, that whisker stops right there. But again, it's all coming from the middle out for box plots. The heart of the box plot is the median. 50% of the data points lie above that. 50% of the data points lie below that. The next layer of this onion are the hinges, and this is saying that for the hinge, the top hinge, only 25% of data lies above the top hinge. For the bottom hinge, only 25% of the data lies below the top hinge. And then even farther out, we have the whiskers. And this whisker is really saying, above the whisker, I think of these things as outliers. Below the whisker, I think of these things as outliers. So again, it's all about like median, middle, kind of typical, and then extremes. Like we're all going out. But the big ideas here are the wider the interquartile range, the bigger the spread. The higher this box is shifted up, the higher the distribution is. And anything outside these whiskers can be considered kind of outlier-ish, even if that definition is not perfectly precise just yet. So boxplots are a great way to visualize these distributions, not only kind of in a qualitative sense, which you could get from a histogram, but also in a much more quantitative sense, because now we can really start to say like, oh, like 50% of observations fall within this range. That's a much more quantitative statement that we would be able to make with a lot of other visualization methods.